Hi guys, this is Mark. In this video, I will talk about an aspect of the Backendless database design that becomes very important when you work with relations. It equally applies to all types of relations that's supported by Backendless, including one-to-one, one-to-many, and many-to-many. And this aspect is the fact that relations in Backendless are bidirectional. What this means is that when you establish a relation, whether it's one-to-one or one-to-many, between two different tables and subsequently between the objects in these tables, we have discussed that there is a parent table and there are child tables, and there is one child table in the case of one-to-one, but that relation between the objects goes both ways. There is an explicit relation that goes from parent to child, but there is an implicit relation that goes from child to parent. And it becomes very important when you work with your objects and your data to consider the fact that those relations are bidirectional. Let me illustrate that with the slide, and then I will also demonstrate that using the API. So consider this schema, if you will, between the table person and passport. We discussed that when we just started looking into the relations. So here I have a one-to-one relation from the person table to the passport table. And this means that a record in the person table may have a reference, it may have a related object in the passport table. So this means that whenever you work with person, you could have a related passport, and that's what we have looked into, where for a given person you can retrieve the related passport. In fact, if we take a look at the actual schema, you will see that in the person table there is a relation column called passport, which is a one-to-one relationship column pointing to the passport column. However, if you take a closer look, and we will take a look at it in Backendless console, you will see that there is a sort of a pseudo column called person and then passport in square brackets. And that pseudo column, it is not really a relation column, it's sort of a suggestion or a reference indicating the fact that there is a parent table called person. In fact, when you look at this syntax, I guess, the first part is going to be the name of the parent table, and then whatever you have in the square brackets is going to be the name of the column in the parent table that points to this one. And by having this in place, and it is automatic, as soon as you create a relation column in the child table, this will be created as well. You will see that it's there, and it is there for the reason that you can actually use it in your queries, and it becomes very, very helpful. Let me demonstrate how this works in action and how you can start using it in your applications. So here in Backendless console, this is the table called person, and I have it exactly the same way as we have left from one of the previous lectures, where these two records, they have corresponding passports. Okay, so in fact, if we go to REST console and start using API to retrieve that data, then in here we can say, okay, I want to get a record, a person record, where name equals Joe. And in the relations, I can specify that I want to get a corresponding record from the related passport table, because passport is a relation column declared in person. So when I click get, I do get this record for the person whose name is Joe, and I have the related passport. And that is great. So that relationship here works in the way where from parent table, which is person, I retrieve a related record from the related table called passport. Now, let's take a closer look at the passport table, specifically in the data browser. In here, there is this column. I moved it because normally all of these will show up at the very end of the data browser. So if you want to move it up, just click on columns and you will be able to move this column around. So by default, it will look like this, where it's at the very end. So what I did is I brought it over to be the first one, and using this columns drop down. So notice that here it says relation from, and it has the syntax that I just demonstrated in the slide, where it shows person and then passport in square brackets. So this is a pseudo column. That's why it is displayed differently than all other columns in this table. So what this does is it gives you an indication that there is an incoming relation from table person. Column name is passport. Okay. And by having this in place, you can actually start using it in your applications to do the reverse lookup from child to parent. And this is how that reverse lookup will work when you start structuring your queries. So let's go to REST console. And in here, we can actually start referring to that pseudo column like this. So we say person, and then we put passport in square brackets. Okay, so this essentially identifies a reference to the parent object. And by having this in place, we can actually start referring to the properties of the parent object. So now if I put name equals Joe, okay, because name is a column in the person table, I can actually use it in a query. So now I'm going to be retrieving a passport object that belongs to the person with the name Joe. So click get, and now we get the passport that actually belongs to Joe. And since we're doing a retrieval from the passport table, then it's going to be just the passport object. But we know that that passport object belongs to Joe. Okay, and here I'm just pinpointing a specific user. If we want to get, for instance, all the users that actually have passport, you can use it the same way. So we can say person and then passport in square brackets, object ID is not null. That means that give me all the passports for all the users that actually have passports. So and this is what the query looks like. Click get, and these are all the passports that actually have a legitimate user. Okay, and that demonstrates how the bidirectional nature of the relations can become very, very useful. Here's another thing that is also quite important and useful. Since we do have that bidirectional nature of the relations, and we can reference the parent table, what we can do is we can bring data from the parent table into the response itself. So not only we get the passport information, but we can add additional data from the object that is the parent object. And to do this, we can use the API to request specific properties. So this format right here, where we have name of the parent table and the relation column in square brackets, we can use this when we retrieve specific properties. So in here, what we can do is we can say person, square brackets, passport, dot, for instance, name. Okay, so what we're doing here is we're requesting name of the person that owns that specific passport. And this will bring just the name, and it will rule out all other properties, because when you request a specific property, you will be getting just that specific property. But there is a shortcut to get all other native properties of passport in this case. And if you put star, that means that give me all the properties of the passport plus the name of the passport owner. So click get, and notice that we got here, in addition to the passport information, we got the name Joe. Okay, and then you can assign an alias, and you can say passport owner, and that will become the property name. Click get. Now we have passport owner Joe plus all the data from the passport table. Now this star thing is something new. I haven't discussed this before, and then it becomes quite useful when you want just to say, give me all the properties from that native object. Without it, if I exclude it, notice that you get just the passport owner. So by having star here, you get all the properties of the passport. And then in here, you can reference just pretty much any property that exists in the parent object. This works not only when you have two tables linked with each other with relations. You could have the chaining effect of multiple tables. And by having this mechanism where you can reference parent, and then if the parent object had other relations, you can continue that chaining effect using the same mechanism of referencing the related properties. Let me demonstrate how this worked just by using some other tables that I have here. So for instance, person table, let's say that that person has a relationship to this review table, okay? And then let's just create that relationship. And let's just say reviews or review. For now, we'll just stick to one-to-one. And that's going to be a data relationship to the review table. Click create. So now we have in the person table, we have the review. So let's say that that person, Joe, left a review, and then we will add the relation here. And then the person with name Anna also left a review. So now what we have is from person, we can navigate to the review that they have left. Okay, I'm just trying to demonstrate how the chaining effect could work. So what we have here is in the review table, we have, let's say, body. Okay, that's the body of the review that they have left. Now, if we go back to passport, okay, and here we can say, well, we're going to be still working with, let's say, person Joe. So we say person, passport, name, equals Joe. And that will give us the passport that belongs to Joe. We already know that. There's a little typo here. So here it is. So this is the passport that belongs to Joe. Now we want to bring the name of the passport owner. And we know we can do that by requesting a specific property, person, passport, dot name. And star. So it's nothing new yet. We're basically rebuilding everything we can. But let's also, for some reason, you want to get the actual body of the review that they have left. In this case, what we do is this: person, passport, and then from here we know that there is a relationship column called review, and then review has body. So we'd say dot review dot body. Okay. And this will bring the actual body of the review that the person left. Click get. So now here we got the data not only from the parent table, but some other table that the parent table is related to. And that's how you can basically just traverse pretty much the entire schema so long that there are relations in it. And it becomes very, very powerful mechanism. Of course, the point of this video is to demonstrate the fact that the relationships are bidirectional, but I kind of went a little bit over that concept to demonstrate how you can do the traversal of your schema, and we will have another lecture on this topic. But the main point was just the fact that you need to keep in mind that you can always get from parent to child and from child to parent using the syntax of the square brackets. I hope you found this useful. This is a very important concept, and I want to make sure that it was very clear and you understood it. If you have any questions, please leave a comment. I will be happy to clarify. That's all as far as bidirectional nature. Thank you for watching this video, and as always, happy coding.